All right, let's just picture the absolute worst case scenario. A building has collapsed, the clock is ticking, and for anyone trapped inside, every single second is a lifetime. For the first responders on the scene, their greatest enemy is time, and the biggest challenge? Finding survivors they can't even see. But what if they could see through the rubble? See, even when you're in total darkness, buried under tons of concrete and steel, the air isn't empty. It's actually filled with radio waves, with ordinary Wi-Fi signals that are already passing through solid objects. And now, there's a technology that can actually read those signals to find the faintest signs of life. You know, in any disaster, rescuers always talk about the golden hour. That's that critical window where the chances of finding someone alive are the highest. But honestly, the tools they've had to rely on are often just no match for the chaos of a collapse site. I mean, just think about what they're up against. You've got dust and smoke so thick it creates total zero visibility, which makes cameras pretty much useless. The debris is often way too unstable for rescue teams to just go charging in. And those sensitive listening devices, they're easily drowned out by wind, shifting rubble, or the noise from their own machinery. Every one of these challenges just eats away at that precious golden hour. Okay, so this is where everything changes. Instead of trying to physically see or hear through all that debris, this new approach uses physics to create a completely new kind of sight. And the best part? It's built on hardware that is surprisingly, and I mean surprisingly, common. So here's the big idea. It's a portable mesh network of small, really inexpensive sensors. A rescuer can literally just toss these into a disaster zone, and they immediately start talking to each other, analyzing the Wi-Fi signals that are already bouncing around in there, looking for the tiny disturbances caused by a living, breathing person. And get this, the cost for a starter kit of these little sensor nodes, it's about $54. No, that's not a typo. $54. That is a tiny fraction of what traditional gear costs, which makes this tech incredibly accessible for pretty much any rescue team anywhere in the world. And the difference this makes out in the field is just night and day. On one hand, you have this ESP32 mesh. You can deploy it in seconds, it sees right through concrete, and this is absolutely crucial. It runs entirely offline. No internet, no cloud, no cell service needed. It just works. On the other hand, you have traditional systems that are wildly expensive, need a clear line of sight, and are basically useless in heavy smoke or dust. So that leads to the really big question, right? How on earth is this even possible? How can a simple radio wave, a Wi-Fi signal, do something so incredibly complex? The physics behind this is it's amazing. We're talking about detecting the tiny, rhythmic movement of a person's chest rising and falling from a distance through solid material. I know, it sounds like something straight out of science fiction, but it's based on a very real property of radio signals. The secret sauce here is something called channel state information, or CSI. The easiest way to think about it is that every Wi-Fi signal has a story to tell about its journey. CSI is the detailed record of that story. It's like the unique fingerprint of the signal's path from a transmitter to a receiver, capturing how it was affected by every single thing it passed through, bounced off of, or got absorbed by along the way. The best analogy, by far, is the ripples on a pond. Imagine the Wi-Fi signals filling that collapse zone are like the perfectly still, glassy surface of a pond. Now, when a survivor takes a breath, the tiny movement of their chest creates these almost microscopic ripples in that Wi-Fi field. The sensors in the system are so incredibly sensitive that they can pick up on these tiny ripples. And more importantly, they can recognize the rhythmic pattern of breathing or a heartbeat, which allows them to tell it apart from random noise, like settling dust. But you might be asking, what about all the other noise? A disaster site is chaotic. Well, that's where the smarts come in. The system first builds what's called a persistent field model. It's smart enough to learn the unique radio frequency signature of the rubble itself, the static environment. Then it just subtracts that baseline from its readings, which effectively makes the rubble invisible and isolates only the new disturbances, the ones caused by human vital signs. So we've got the science down. Now let's get practical. Let's look at how a first responder actually uses this information on the ground to make those split-second life or death decisions. This is it. This is what the rescuer sees, right, on the little screen of their handheld device. It's not a bunch of complicated data. It is exactly what they need and nothing more. A breathing rate, a heart rate, and a confidence score. And remember, all of this is processed right on the device itself, instantly. No external computer, no internet, no waiting. And here's why that simple data is a total game changer. It plugs directly into the universal START triage system that first responders use all over the world. So for example, let's say the device detects breathing, but no movement. The system instantly classifies that survivor as red, immediate, priority 1. That's not just data, that's a direct command. It tells the rescue team, this person needs help right now. It completely removes the guesswork. And this mesh network isn't just a bunch of dumb sensors. It's practically an intelligent, resilient organism. It's self-learning, so it automatically adjusts for different kinds of debris, concrete, steel, wood, you name it. It's also self-healing. If a sensor gets crushed or a connection drops, the network just reroutes itself and keeps on tracking. It uses this sophisticated graph-based reasoning to tell the difference between a human heartbeat and the wind, and it can even distinguish between multiple survivors in the same room. So the crucial point, the main takeaway, is this. It provides complete spatial awareness under the worst possible conditions imaginable. In situations where human eyes and expensive cameras are totally blind, this system gives rescuers a clear, life-saving picture of the unseen. When you put all of these pieces together, what you have isn't just a small improvement on existing tools. This technology fundamentally changes the rules of search and rescue. It all boils down to 3 massive advantages. First, speed. You're getting instant detection versus hours of slow, dangerous manual searching. Second, cost. It's exponentially cheaper, which means literally any rescue squad can afford it. And third, safety. By finding people remotely, it keeps rescue personnel out of the most unstable parts of a collapse until they know exactly where they need to go. It's faster, it's cheaper, and it's safer. Period. So really, this isn't just about a cool new piece of tech. This is about giving first responders a new sense, the ability to see life through solid walls. And so I'll leave you with this thought. What happens when every single rescue team in the world can see the invisible?